Hey guys, hope you're well. So here we have another exam paper. This is Eastern Cape, September 2025, Maths Paper 1. If you want to download the paper, check the description below. So we start with this question over here. Very simple. All you need to do is just take everything to the one side, make the other side equal to 0, factorize, and this should factorize as x plus 3, x minus 1. And so if you had to go and solve this, you would eventually see that x is minus 3 or x is 1. This question here says correct to 2 decimal places. So that is a hint that you would need to use the quadratic formula. Now, step 1 with the quadratic formula is you want everything on the one side and the other side must be equal to 0, which we have. And so we can go write out the formula. Have you guys ever seen this formula before? Okay, that was a joke. Obviously, you've seen this 150,000 times. So this is A, this is B, and this is C. So we can go for when B is negative, I always put it in a bracket. A is 3, C is 2, and then A is 3. Okay, now you don't need to go and simplify that. You just go and plug it on your calculator now. So the first one you should get is 2.76, or x is 0.24. Here we have an inequality, so step 1, let's just go multiply everything out and just make it look a little bit more easy to work with. I would then take everything to the left, so we can have an x squared that is positive. It just feels nicer to work with it like that. And then on the right hand side, you're going to be left with 0. Now, when you have an inequality like this, and you've got everything on the one side, and you've got a 0 on the other side, this is where you need to go get your critical values. The way that you get your critical values is that you make the equation equal to 0, and then you go solve. You can solve using the quadratic formula, you could solve factorizing. This one will factorize quite nicely as x minus 3, x minus 3. And so if you had to solve this, you would end up with x equals to 3. Then you normally take these numbers. Normally there's 2, but now we're only getting 1. And you go put them on a number line. So we're going to go just put one number on a number line. Then you're going to go and draw what we have over here. So what we have is we have this type of graph, which is a parabola. And parabolas can be smiley face parabolas, or they can be sad face parabolas. So we want to know, the way that you tell if it's happy or sad is you look at the number that is in front of x squared. If it's a positive number, positive people are happy. If it's a negative number, negative people are sad. So this is a positive number, so you're just going to draw. Normally you would have, your number line would have 2 parts, and then you would go through each of those. But when it just has 1, well, what do? Well, then it just means that it does that. Okay. Now this equation tells us, it says, where is this graph greater than 0? So what that means is, where is it above? Or let's say here, where is the graph above the x-axis? Now, something I just came to mind when I was busy saying that is that I don't want you to now go and make a little note in your book and say, okay, so whenever it says that, then it means where is it above the x-axis? Or no, I don't want you to just go put that on your book and say, okay, so whenever you see that, it means above the x-axis, and whenever you see that, it means below. That is not correct at all. It's got to do with, you might have an equation that says something like this, x squared minus 6x plus 9. Now, this and this are actually exactly the same thing, even though these symbols are the other way around. But if you look at it carefully, they are actually the exact same thing. Here on this one, it says that this expression is greater than 0. And then for this one, it says that this expression is greater than 0. It's the same thing. So just make sure you understand what these little symbols actually mean. Okay, so we want to know, where is this graph above the x-axis? So if this line over here is your x-axis, then where is it above? Well, it's above over here, and it's above over here. So it's above everywhere except at that point over there, because at that point over there, it's not above the x-axis, it's on the x-axis. So we can say that x can be any number except x must not be a 3. So that's one way you could write the answer. The other way you could say is that x can be any number smaller than 3, or x can be any number bigger than 3. Or you could even write it as x is an element from minus infinity up to 3, or x is an element from 3 up to infinity. You can use this method, or that method. All three of those are correct. Here we have a double square root. So these, you don't see them that often, but what you want to do is you want to get one of the square roots alone. You can choose whichever one you like. So I'm going to keep this one on the left, and then I'm going to take everything else to the other side. So we're going to end up with 1 plus square root x. And now we're just going to do the normal, so you're going to square both sides. Now remember, when you square this side, you don't put a square here and a square here. No, you put a big bracket around everything and you square that. So on the left, the square is just going to cancel the square root, so you're just going to be left with x plus 5. Now on the right, many learners make a mistake here. They think, oh, I'll just put the 2 on the inside and on the inside there. No, you want to make 2 brackets. So you're going to get this and that. Now we're just going to go multiply the 2 brackets together. So it's going to be 1 plus square root x plus another square root x plus. Now when you multiply these two together, we know that there's a rule that says if you multiply 2 things together, you can just multiply them like that. So this is going to become the square root of x times x, which is x squared. But what is the square root when there's a square over there? Well, the square root is just going to cancel out the 2, and so you're actually just going to end up with that becoming x. So there's another rule that if you take 2 things that are exactly the same and they're both inside a square root and you multiply them together, you actually just end up with a, or you end up with whatever is on the inside. So we're actually just going to end up with x over there. So now we're going to have x plus 5 equals to 1 plus. Now if you have square root x plus another square root x, that means you have 2 square root x plus x, because this just becomes plus x. Now this x and this x are eventually going to cancel, and so I'm going to take this 1 over to the left, so you end up with 5 minus 1. And now all of a sudden we're getting to quite a simple type of question. I'm going to take the 4 and I'm going to take the 2 to the other side, so I divide it by 2, so I end up with 2 equals to square root x. Now what I do is I square both sides, and I end up with 4 is equal to x. Now, as I always say with square root equations, you always want to go and do a little check. So we only have one number that we need to check. So if we check on the left side and we check on the right side of the equation. So all we do now is we go take x equals to 4 and we plug it into the place of x. So let's see what the left side will be. That'll be 4 plus 5 minus that. That's going to give you 3 minus 2, which is 1. And on the right hand side, we only have a 1. And so we can see that the right hand side and the left hand side are the same, and that's what we want. And so this is a valid answer. Step 1 when doing simultaneous equations is take the easier looking equation, so that's definitely this one, and then get the x or the y by itself, whichever one's going to be easier. So I can get this y by itself, so I'm just going to take it to the left, and then I'm going to bring this to the right. So you should eventually end up with that. I'm now going to take this expression and I'm going to substitute it inside here. So what it means is that I'm going to replace all of the y's with 1 minus 2x. And so we're going to end up with 1 minus 2x squared, which is this part, minus 2 bracket 1 minus 2x, which is this part, minus 3x plus 1 equals to 3x bracket 1 minus 2x, which is that part there, and then minus 2x squared. Now, what many learners do incorrectly here is they think that they can just go put the 2 inside to both of those places. Instead, double brackets. We can then multiply this inside, so that'll become minus 2 plus 4x minus 3x plus 1 equals to 3x take away 6x squared take away 2x squared. Okay, now we're just going to go multiply these two brackets together. So you're going to end up with this. Right, now we just want to simplify. So I'm going to, okay, there's different ways you can do this. There's so many different ways, but I'm just going to put everything here on this side. I'm going to simplify. So with the numbers, we've got 1 minus 2 plus 1. So that actually ends up becoming 0. So all of those numbers cancel out. Then for the x's, minus 2 is minus 4 plus 4. So that's 0. And then minus 3x. So we're going to have minus 3x on the left. And then 4x squared, okay, that's the only thing we have. So on the left, that is what we have. On the right, we have 3x, and then we have minus 6 minus 2, which is minus 8x squared. Now we take everything to one side, so I'm going to take everything to the left. So we're going to end up getting minus 3x plus 4x squared minus 3x plus 8x squared equals 0. And then we end up with 12x squared minus 6x equals 0. Now a common error here, this would be wrong, is learners think, oh, okay, so I'm just going to take the 6x to the other side. I'm then just going to divide both sides by 6 and both sides by x. It's not correct, guys. What you rather do, take out a common factor over here. So the common factor is 6x, and then you'd be left with 2x minus 1. And so then you can say 6x equals 0, or 2x minus 1 must be equal to 0. And so if you had to go and solve, you should end up with x equals to 0 or x equals to 1 over 2. Now we just need to get the y values, so we come back to this easy equation over here. And so if x is 0, then you're just going to end up with 1. And then if x is a half, then you just end up with y equals to 0. So there's our four answers. We've got the two x values and the two y values. Given that k is equal to that expression and p is equal to that expression, determine the value of p if this. Okay, so when I read that, I honestly have no idea what the heck is actually going to happen, but let's just go, I think let's go and start. Determine the value of p if that. Okay, so let's go, let's just go use this to try help us find k. Now, we've currently got that over there. Now, we know that this can be rewritten as, remember, if you've got something like a to the b, and then this over here is a c, then the rule is you can always rewrite it as a to the inside number over the outside number. Example that you often see is like x with the square root. So the inside number is a 1, and if you don't see a number here, then it's a 2. So you'll often see your teacher rewriting this as x to the inside number over the outside number. So we'll do the same thing here. So that's going to be k to the inside number over the outside number. There we go. And then we've got 4 to the 1 over 6. So there's a rule in mathematics that if, well, no, let's do it like this. If you have these two numbers being the same, then you can ignore them. And then you can just go solve the tops. But it also works the other way around. If you have the tops the same, so if you have like, if you have the top parts being the same, then you can ignore those and you can just use the bottoms. So what I notice is that I can change, I can get these to become the same by doing the following. I can change 4 to 2 to the power of 2, and I know that exponent rule says that I should multiply these. And if you multiply those, you end up with 1 over 3. So we now have these being the same. So then we can ignore that and we can just say k equals to 2. So what I would then go do is let's go fill in this k value of 2. So that's going to be 1 over x squared plus 7x plus 5. I would then use cross multiplication because this is 2 over 1. So you would end up multiplying this up there and you'd multiply this up there. So you'd end up with the following. And then if we just had to go in, or actually, what we could maybe do now is, can you see that these two expressions are almost the same? Okay, so what we can do, I don't want to multiply the 2 in because then I end up with a 2x squared, whereas these are all just 1x squared. So what I'm rather going to do is divide by 2 on the other side, so you end up with that. Now, I know that p is 1 over x squared plus 7x plus 7. But here I have x squared plus 7x plus 5. So, you know, if this was a plus 7, then you would say that this is equal to a half, and then you could just replace this with a half. But the problem is that we have a plus 5 here. But that's really easy to solve, because at the moment we have this. So in mathematics, you can, if you want to add something on this side, you are allowed to do it as long as you do it on this side. So if I add the number 2 over here, and I do it on this side, then this becomes plus 7, and then this becomes 5 over 2. So what we are now saying is that this expression is equal to 5 over 2. And so I can replace this expression with 5 over 2. And then if you had to go type that on your calculator, you'd end up with 2 over 5. Two learners, Amanda and Leroy, ooh la la, were given a task to come up with any common ratio that would be suitable to calculate. Like, who does this on a first date? Like, seriously, go do something fun, guys. That would be suitable to calculate the sum to infinity if it is given. Okay, I'm not focusing. Two learners, Amanda and Leroy, were given a task to come up with any common ratio that would be suitable to calculate the sum to, like, imagine you land up on your first date and good old Leroy's like, hey, so Amanda, I kind of planned something quite exciting for us this evening. And now Amanda's like, oh wow, like I wonder what it's gonna be. Like, are we going on a hot air balloon, or maybe we going on like a nice boat ride, you know, and we're gonna have champagne and nice things like that. And then suddenly Leroy pulls out his that sounds so bad. Oh, terrible. He pulls out his exam pad and this is terrible. He pulls out the exam pad and he's like, I was thinking that maybe we could come up with a common ratio, you know, that would be suitable to calculate the sum to infinity. And I'll let you know, by the way, I'll make it a little bit more interesting for you, Amanda, because I like you. The first term, A, is 2. Now you can just imagine Amanda sitting there blushing with so much adrenaline running through her veins, like, oh, such a romantic. We're going to do calculus or series and sequences together. Okay, let's focus. Two learners, Amanda and Leroy, were given a task to come up with any common ratio that would be suitable to calculate the sum to infinity if it given that the first term A is 2. Below are the calculations. You know, I've read this 4 times and I still don't know what I'm reading. Sorry, guys, I'm terrible. Two learners, Amanda and Leroy, were given a task to come up with any common ratio that would be suitable. Okay, so they got to find the value of R. If it given that the first term A is 2. Below are the calculations. So Amanda says that A is 2, R is 3. And then when she went and did her sum to infinity formula, she got -1. And then when Leroy went and he used A as 2 and R as a half, and when he went and did a sum to infinity, he got 4. Right. So they want to know which learner's response is incorrect, and that's for 1 mark. So we know that sum to infinity is A over 1 minus R. And sum to infinity, you only use that on converging sequences. And converging sequences, so let's just make a note for ourselves here. Sum to infinity only used on converging sequences. Now, converging sequences is when R is any number between -1 and 1. So it's any number between -1 and 1. So R equals to 3 is not between -1 and 1. So Amanda is using the wrong, well, she's using the wrong formula. You can't use sum to infinity if it's not converging. Clearly, Leroy is not going to be happy with that date. Hashtag Amanda just catfished him. On the dating app, nerdalert.com, Amanda said that she was like really good at mathematics, and so Leroy was really intrigued by that, and now she's just catfished him. So which learner's response is incorrect? Amanda. What question is this even? Like, I feel like we're doing English at the moment. Hence explain why the learner's response is incorrect. We can say that something along the lines of sum to infinity can only be used on converging sequences where, and then we can say the following, and then we can just say something like 3 is not within the interval. Let me just write this a bit better. Interval. Evaluate. So this is a pretty straightforward question. There's nothing funny about this. All we need to go and do is go work out, is this arithmetic or is it geometric? So to do that, you go find the first 3 terms. So term 1, term 2, and term 3. To find term 1, you take whatever this number is and you plug it into the expression. So that's going to be like that. And this would eventually give us 3. Then you just go, for the next term, you just increase the number that you had over here by 1. So that's going to be a 2. And so that's going to be 6. And then you just do it once more. So it's going to be a 3. And that's now going to be 12. So we can now see that we're going from 3 to 6 to 12. So we're multiplying by 2. So we can see that the common ratio is 2. So now all that sigma actually means is sum of. So we can go use the sum of formula now for a geometric, which is this. You can also use the one where you put the r minus 1 and r minus 1. That is also fine. Now, let's go and work this out. So a is term 1, which is 3. R is the ratio, which is 2. Now the number of terms is always going to be, so your number of terms is always going to be the top of the sigma minus the bottom of the sigma, and then you must always plus 1. So it's going to be the top number minus the bottom number plus 1. So in this case, it's going to be 10. But that doesn't mean that it's always whatever this number is. It's only because this number here is a 1 that it's the same as this, that the number of terms is the same as this. But if this was a 2 or any other number, then this would not be the same as the number of terms. So please always use this formula to calculate your n value. Okay, so we've just found that there are 10 terms. So we can put a 10 over here, and then 1 minus r, which again is 2. Go ahead, type that all in, and we should get 3069. Which term of this sequence, 8, 6, 9 over 2, and then it carries on, will be the first one to be less than this number? So let me explain. What we have is we have a sequence that goes 8, then it goes to 6, then it goes to 9 over 2. And so we can see that these numbers are getting smaller and smaller and smaller and smaller. And eventually, there will be a number that will be less than 1 out of 100. Okay, so we first need to figure out what type of pattern do we have here. Now we obviously have 2 main types. We've got arithmetic and geometric. Arithmetic is when you have something like 20, 18, 16, 14. So you can see that you either adding or subtracting a constant number. And then we've got geometric patterns where you are going, for example, 100, 50, 25, 12.5. So what you can see is that you are multiplying by a half each time. So you're multiplying by a certain number. So with geometric, you're multiplying by something, and with arithmetic, you are adding or subtracting something. So the way that we go and see is, let's first check if it is maybe arithmetic. Okay, so to see if it's arithmetic, we would go and say term 2. Let's go work out what is term 2 minus term 1. So term 2 minus term 1 would be 6 minus 8, which is minus 2. And then if you had to go see if that same difference is between those numbers, you would take term 3 minus term 2, and that would be 9 over 2 minus 6, and that's going to give us negative 3 over 2. So we can see that the differences are not remaining constant, so it's definitely not arithmetic. So then what we do is we go see if it's geometric. So then what you do is you see what is this number divided by this number, and that'll be 6 over 8, which simplifies to 3 over 4. And then what you see is, does it stay 3 over 4? So then you're going to take 9 over 2 divided by 6. And if you had to work that out, you also get 3 over 4. So what we can see is that the ratio is constant. It's 3 over 4. So we can say then that the ratio is 3 over 4. Now they want to know which term is going to be less than 1 over 100. So, if these numbers had to keep going on, eventually there will be a number that is less than 1 over 100. So then what we can go do, let's just go write out the formula for geometric. And if we're trying to find a specific term, we're not trying to find the sum. They said which term. So we're using the TN formula. And let's just go use 1 over 100. And so A is term 1, which is 8. R is 3 over 4. And then N minus 1. Now, you cannot multiply this 8 inside here because of this part over here. But what you can do is you can divide this 8 on the left. So you could have 1 over 100 all over 8. And then on the right, you've just got that. And so that part on the left, 1 over 100 divided by 8, is going to be 1 over 800. And then on the right, we've got this. Did someone just say logs? Yep. So we need to use logs here because these two numbers are not going to be able to become the same. And so logs is our only backup. So, learners get confused on how to switch this to a log. All I want you to understand is the following. This number here, we call this the base. It's the one that's written under this exponent. So we call that the base. Now, when you switch this to a log, I want you to keep the 3 over 4 as the base. So when you write out a log expression and you've got like A and a B, this part at the bottom is called your base. Okay, so when you go write out your log expression now, the base stays the base. So we're going to say 3 over 4. And then this part and this part are now going to switch places. So the 3 over 4 was with the n minus 1. Now it's going to be with the 1 over 800. So we put it with the 1 over 800. And then on the other side of the equal sign, we now put the n minus 1. So all that happened was that this 3 over 4 stays the base, and then it simply switches place. So instead of being written with the n minus 1, it gets written with the 1 over 800. And so you can now go and type this on your calculator. And don't be surprised if we're not going to get a whole number for n. I don't think we will. So n minus 1 is going to be 23,236. And then if you had to solve for n, you're going to get 24,236. Now, some of you, in fact, many of you who are looking at this right now, you're thinking, something's wrong because my teacher says you can't get the n has to be like a whole number. Now, that is correct. But what we need to understand is that we know that this is the original pattern over here. And then it keeps going. And then they said which term will be less than 1 over 100. They didn't say that 1 over 100 is a term in the pattern. They just said when is the first term that will be less than 1 over 100? So what we then found was that 1 over 100 would have happened at n equals to 24,236. Now, obviously, you can't have an n value of that. So if we then had to look at the term that would be just before this one, so that would be term number 24, and then the term just after that would be term number 25. Remember that this is term 1, this is term 2, this is term 3, and then we go on and on and on and on and on and on, and eventually you would get to a term 24, and then there would eventually be a term 25. So we know that as the terms are going on, or as the numbers are going, they're getting smaller and smaller and smaller. So term 24 would still be larger than 1 over 100. So this would be larger than 1 over 100, whatever this number would have been, okay? And then term 25 would then be a number that is smaller than 1 over 100, because as we go to the right, the numbers are getting smaller. So they said which term in the sequence will be the first one that will be less than 1 over 100, and so that would be this one over here, and so that would be term number 25. So just once again, yes, you cannot have a term number that is a decimal, but it still helps us to get an idea of where about 1 over 100 would have been. And then we can just realize that, okay, so that would be between term number 24 and it would be between term number 25. So the answer is going to be term number 25. The following information about a quadratic number pattern is given. So they tell us that the difference between term 2 and term 1 is -4, and then the difference between term 3 and term 2 is -3. So, and then they say that the fourth term is equal to 1. So what we can do is we can say that the first term is x. Then if we know that the first difference is -4, then this would be x minus 4. Then they say that the next difference between term 3 and term 2 is -3. So that would be over there. So then this would be x minus 7. And then they tell us that the fourth term is equal to 1. Okay. Now, we know that this is quadratic. So if you had to look at the difference between these two numbers, that would be a +1. And we know that with a quadratic, that stays constant. So that would have to be a 1. So that means that this would have to be a -2. -2. And then that would mean that, okay, we don't need the next term. So that is kind of what our quadratic pattern is looking like at the moment. And so the first question is, find the formula. Okay, quite an interesting quadratic. One of the more, I wouldn't say challenging, but definitely one of the more interesting ones I've seen. So we know that to find the formula, we would say 2a is equal to that, 3a plus b is equal to that, and then a plus b plus c is equal to that. But I don't think this is going to work. It will allow us to find a, it will allow us to find b, but then this part here is going to be a bit weird because that's going to be x. So we can use this information here to find x. We can say that if you take x minus 7 and then you add on the difference, which is -2, it should give us a 1. All we're saying is that this plus this difference should give us 1. Now, obviously, that's just going to become a negative. So it's just going to be x minus 7 minus 2 equals to 1. And so if you had to solve, we'd find out that x is going to be 10. Okay, so we have x. So now we can go and solve the way we normally would. And so 2a is equal to 1. So therefore, a would be a half. Then 3a plus b is equal to -4. But a is already a half. And so if you had to go and solve for b, you should end up with -4 minus 1.5. And then b would end up being -5.5. Or that is the same as 11 over 2, which is what they kind of have there. Well, not kind of, that's what they have there. And okay, now to find a plus b plus, or to find the other one, we know that that's equal to x, but we've just found out that x is 10, so we can go fill everything in. Okay, and if you had to solve for C, you would eventually get 15. Fantastic. So we went and got everything over there, and so we can then say, therefore, Tn would be a half n squared minus 11 over 2n plus 15. This question says, determine the value of term 16. So that's pretty straightforward. All we're going to go and do is plug in n as 16. Like that. Go ahead, type it in on the calculator, or solve it in your head if you're cool like that. But you should end up with 55. This next one's pretty straightforward. It says, which two terms in the quadratic pattern will have a difference of 45? So remember that this line over here is your first differences, and that's what they're saying. They're pretty much saying, when in this pattern would we eventually have a number that is going to be 45? Now, there's two ways to do this, whether you want to use more of a grade 11 kind of approach or more of the grade 12 approach. So if you do the grade 11 method, now some schools do show the grade 12 method already in grade 11. So, but typically in grade 11, you would use a formula like an plus b, because this is a linear pattern. Remember, linear means that you're just adding or subtracting the same amount every time. For example, 5, 7, 9, 11, 13. That is called a linear pattern. Grade 12s, that's what you'd call an arithmetic pattern. It's the same thing. It's when you add or subtract the same number every time. So here you can see that you are adding 1 every single time to go from one term to the next term. You're just adding 1. Okay, so in the grade 11 method, or let's first go find our A's and B's. So A is always going to be the difference. So the difference between one term to the next is 1. So we'll just put a 1. And then your B value, there's different ways of finding B. You can either substitute one of these numbers in, or you can just go work out what the term before this one would be. So if you had to go back once more, this would be minus 5. And that is what your B value would be. Okay, so there's the formula that you get. Now, if they want to know what is the, which term is equal to 45, then you would plug in 45 over there. You don't plug in 45 there, because now they're not saying what is term 45. They're saying which term is 45. It's different, okay? And so that's just going to be n minus 5. And so if you had to solve, n would be 50. So it means that if you had to keep going, this is term 1, term 2, term 3, term 4, term 5. Eventually, if you get to term number 50, the value that you would find there would be 45. Now for grade 12 learners, and for any grade 11s that maybe use this formula instead, you would use the arithmetic formula, which is a plus n minus 1 times d. But now the a is not the same as the a over here. They're two different things. So in this formula, a is your term number 1, which is minus 4. Okay, it's not the minus 5. That's actually term 0. So we would go minus 4. Okay, and then we'll just leave it as n minus 1 for now. Now d is the common difference. So it's the difference between each number, and that's the 1 that we have. Now they want to know which term value is going to be 45. So you would plug in 45 over here. And then this 1 is not really going to do anything, so you're just going to end up with that. Then if you eventually had to go and solve this, you should eventually end up with 50. So it means that term 50 is going to be equal to 45. Given that Sn is equal to 2n squared minus 6n, first question, calculate the sum of the first 30 terms. So some learners do get a bit confused when they give us a Sn formula. But all you need to understand is that the S means sum. So this already is the sum of. So if they want the sum of the first 30 terms, then you literally just go plug in 30 in the place of n. And if you had to go work this out, you end up with 1,620. Now with this next question, we need to spend a bit of time just understanding what they mean, because I do notice that some learners do get confused with this, and it's actually a really easy concept, but if it hasn't been explained to you, or if it hasn't been explained in an easy way, then it can be weird. I'm going to quickly just make up my own little pattern. So let's say we had an arithmetic pattern which was 5, 8, 11, 14, and 17. So that's an arithmetic series. Now, if I had to go and quickly say, what is the sum of 3 terms? The sum of the first 3 terms. Then you would say 5 plus 8 plus 11, and that would give us a value of 1324. Okay. Now, if I had to go say, what is the sum of the first 4 terms? Well, now it would just be 5 plus 8 plus 11 plus the 14. And so that would just be 38. Now, what is the only... so when you take... let me rather say this. If you take the sum of the first 3 terms, you're doing that. And if you take the sum of the first 4 terms, then you are doing that. So what is the only difference actually? It's just the fact that we're adding on the 14. So then, if I want to know what is term 4 equal to, I can just take the sum of the first 4 terms and I can subtract. Let me write this somewhere else. So if I want to find term 4 mathematically, I can just take the sum of 4 terms and minus the sum of 3 terms. And that'll give us 38 minus 24, which is the 14. Another way of writing that is, we could have rather written it as the sum of 4 terms is 5 plus 8 plus 11 plus 14 minus, in brackets, 5 plus 8 plus 11. And so if you had to get rid of the brackets, you would have minus 8 minus 11. And so the 5s are cancelled, the 8s are cancelled, the 11s are cancelled, and then you're just left with the 14. So there is a formula that says if you want to find the a specific term value, term n, all you need to do is take the sum of those n terms minus the sum of n minus 1. So what that means is that if you want to find term 4, you take the sum of 4 terms, so that's why these are the same. You can imagine 4 and 4. And then you minus the sum of 3 terms. So you see how 3 is 1 less than 4. Just like n minus 1 is 1 less than n. And so this over here is a formula that you can remember, okay? To find a specific term value, you just need the sum of that term value, the sum of that same term number is what I meant to say, minus the sum of the terms one before that. So now all that we can do for this question over here is we can just use this formula. So we can say 300 is equal to Sn. Now Sn is this. So it's going to be 2n squared minus 6n. Then the formula says minus. And now we need to minus Sn minus 1. So S of n minus 1 is just going to be this equation, but all of the n's are going to be n minus 1's. So it's going to be like that. And then remember, we must put this in a bracket. And then this will be in bracket n minus 1, like that. Okay, and now we go and solve. So 300 is equal to 2n squared minus 6n. Minus. Now let's go and clean this bracket up first. So here you cannot put the 2 inside because you've first got to take care of that. And this 2, you cannot put it inside because you rather have to make double brackets. And then here I'm just going to put those 6 in, so minus 6n plus 6. And so let's carry on. So 300 is equal to 2n squared minus 6n. I'm still going to leave this for now. I'm not going to put the minus in just yet. I want to first simplify all of this. So just to save time, this part over here is eventually, after you've multiplied these two brackets together and then you've put the 2 inside, it should give you 2n squared and then minus 4n and then plus 2. Okay, that is after you've done those two brackets multiplied together and then you've put the 2 in and you've put the n squareds and the n's and all of that together. Okay, I'm just trying to save us a bit of time because most of you, are very comfortable with doing that. And so 2n squared. Now we can go and put this negative inside. Well, in fact, let's first simplify this bracket a little bit. So it's going to be 2n squared minus 4 minus 6 is minus 10, and then plus 8. And then 300 equals to 2n squared minus 6n minus 2n squared plus 10n minus 8. It's very important that whenever you minus a term in maths, you always put it in a bracket. Okay, if any of you are getting this incorrect, it's probably because of that. And so minus 6n plus 10 is going to be 4n and then minus 8. And so 4n is going to be 308. And so n is 77. Given the function f equals to 3x minus 5, this is suspicious. Why are they giving us such simple equations? I'd be stressing right now if I was you. Given the if I was a student in an exam, I'd be like, yay, what come now? So the function is equal to 3x minus 5, and they tell us that we only in the interval, so that's kind of like our domain, okay? Bro, wat gaan nou aan? Play nice, man. Okay, so then this question over here says, determine the equation of the inverse. Okay, that's easy. So we know that we have 3x minus 5. Then if you switch, for inverses, step 1, switch x and y around. Okay, then get the y by itself again. So you bring the x plus, you bring the 5 over, and then you have that. Now, if you divide everything by 3, you should end up with a third x. You could also say x over 3 plus 5 over 3. Now it says calculate the value of f5. So that's literally just plugging in if x is 5 into that equation. So that's easy. I'm very suspicious what's going on here. Okay, so that's going to be 10. This one over here says sketch the graphs of f and the inverse on the same set of axes and show the line of symmetry, and then also the coordinates of the end points, because these graphs are not going to go, they're not going to have like arrows just going, because they've limited us over here. So that's going to be interesting because it's going to limit us quite weirdly for the inverse as well. Okay. So I think for now, just to procrastinate and to avoid having to actually do the question because it looks a bit weird, let's just go do the easy part first. Let's go draw our graph. And then let's just go plot the graph of f, because that's pretty straightforward. So to plot a straight line, you just need the x-intercept and the y-intercept. And so for the x-intercept, you make y 0. And so you'd get 0 equals to 3x minus 5. And so x would be eventually 5 over 3. So that is the x-intercept. So we can just say 5 over 3 over there. I'll put the points in just now. I'll put the coordinates. And then to find the y-intercept, you make x 0. And so that's going to be y equals to 3 times 0 minus 5, which is minus 5. Okay, so that would be here. Okay, wait, there's going to be bigger numbers coming along. So let's just put 1 over 5. 5 over 3 would be like there. And then let's put minus 5 there. And then if we had to connect those, now I'm just going to go a little bit through, but we can't go too far because this question is actually going to be restricted to x equals to minus 4 and x equals to 5. That is the domain that they've given us, okay? But I'll finalize that after we've drawn the other graph, and I'll put all the coordinates in. All of that's going to be coming, guys. Don't worry, it's getting super exciting in the house here. Okay, so the next thing is we need to go and draw the inverse. Now, we don't need to use this equation. We know that when you do inverses, x's and y's switch place. So if we know that this coordinate at the moment is 5 over 3, 0, and this coordinate here is 0 minus 5, we can just switch that for the inverse. So if you switch this, it'll become 0 and 5 over 3, which would be there. Okay, and then if you just switch this, it'll become minus 5, 0, which is over there. Okay, well, no, that's a bit far if I'm keeping it according to scale, like there. Okay, so then you're going to get something like that. Well, that was beautiful. Wow. Okay, now let's actually keep everything red and then for that one green. I've just gone and redrawn the graph just to make it look a little bit easier to see. And now the next thing we need to understand is that they also want us to show symmetry lines. Now, when we are busy with inverses, right? These are inverses. Whether we're doing straight lines, exponentials, logs, hyperbolas, parabolas, whatever, the symmetry line for inverses is always the following: y equals x. That is a dotted line, the symmetry line, that is going to go through the origin, okay? And it'll also always go through these places here where the two inverses intersect. So something like that, but it would have been a straight line. So obviously with a ruler, it would have been a lot better, but you get the idea. So like that and like that. So that is that is what the equation is for inverses in grade 12. Do you understand why that line looks the way it does? Why does it go perfectly through the origin like that? Let me explain. It's very easy. It says here y is equal to x. So if x is 1, maybe that's over here, then y would also be 1. So that's why we have a dot there. Then if x is 2, then y would also be 2. Okay, and so you're going to get this perfect line like that. And then if x, for example, is minus 1, then the y value would also be minus 1 at that point. And if x is minus 3 over here, then y would also be minus 3. So the y values and x values are the same at every point. And if x is 0, then y is also 0, and that's why it goes through the origin. So that is the line that of symmetry for inverses. It's the y equals to x line. Whether it's hyperbolas, parabolas, exponentials makes no difference. And remember what I always tell you guys, whenever we do inverses, what is step 1? Switch the x and y around. So the y becomes x and the x becomes y. Well, that's another little indication that this is our symmetry equation, y equals x and x equals to y. So the y becomes x, x becomes y, and this is just something we do with inverses. Now, the last thing we need to do is the end points. So we know that the end points of the original graph is going to be at minus 4 and 5. So for the original graph, that is, which one was that again? That was the red one. So this is the graph of f. So the end points would be at x equals to minus 4 and x equals to 5. Okay, so this x value here would be minus 4. We'll go find the y value for that now. And then this x value here would have to be 5. Because it says the x values are going from minus 4 up to 5. That is like the domain. Now let's go find the y values for those points over there so long. So if we take that equation, f of x equals to 3x minus 5. Now if we plug in the x value of 5, that'll give us 3 times 5 minus 5, which is 10. Oh, we already did that over here. Okay, so we already have that point as 5 and 10. That is the end point over there. Now for this end point over here, that was when x is minus 4. And so that's going to be minus 17. Okay, so this end point would be minus 4 and minus 17. Now, what would the end points be for the other graph? Well, the other graph is the inverse, right? This red one is the original f of x, and the green one is the inverse. Now, all you need to remember is that when you do inverses, x's and y's switch. So this coordinate will become minus 17 minus 4. So that would be this endpoint over here, minus 17 minus 4. And then this one will become 10 and 5. So that'll be here. 10, and 5. And there we go. You've now shown all of the, sketch the graphs and show the line of symmetry. We've done that, and the coordinates of the endpoints. Nice. All right, this equation over here says, well, this question, sorry, calculate the coordinates of the point of intersection. So to find the points of intersection, we always make the equations equal. So we have this equation as 3x minus 5, and then we did have the other one's equation. Now, I'm too lazy to quickly go check what that was. Let's just quickly work it out. So, okay, it was a third x plus 5 over 3. So we now have the two equations. So now we can just make them equal like we normally do whenever we're trying to find out where two things are equal. And there's many different ways you could go ahead here. Some learners would maybe get a common denominator. Others would just combine the x's first. I'm going to do that actually. So I'm going to take the 1 over 3x to the left, and I'm going to take the minus 5 to the right. I'm then going to plug that on my calculator. It'll be 8 over 3, 8 over 3x. And then this one over here would be 20 over 3. Yeah, 20 over 3. Okay, now you can get rid of the 3's. You don't have to. You can just divide by 8 over 3 if you want, but you should eventually end up with an answer of 20 over 8, which would simplify to 5 over 2. So that means that the two are intersecting at that point over there. So that x value would be 5 over 2. And then the y value would be, we just go plug into this equation over here, or you could plug it into this equation over here. It doesn't matter because it's on both graphs. So I'm just going to go plug it into the f of x equation. So that's going to be 3 times 5 over 2 minus 5. And so that'll give us 5 over 2. Okay, so 5 over 2 and 5 over 2. This one, given the following information, f of x is equal to, why coming with a first derivative now, man? No, man, don't be boring. And then, so f of x is equal to this, and g of x is a parabola with a y-intercept at 25 over 6. Determine the minimum value. Uncle, what's going on now, man? No, this means us Jasmine. And so here, this one is for 5 marks. Wow, this looks crazy. Okay. Okay, so I think let's just start over here. They say that f of x, which is 3x, well, let's first say that g of x is they said it's a parabola, so that has the general formula of that. Now, they said that f of x is equal to the first derivative. So let's go take the first derivative. Your eyes means is playing here, man. Okay, so we have that. Now, they said that the equation of f, which is 3x minus 5, is equal to that. So we can then say 3x minus 5 is equal to 2ax plus b. Now, one thing we can do is, they said that f of x is the same as g of x. So they're pretty much saying that the graph of f is the graph of the first derivative of g. So here we have that graph of f. So that graph is the graph of the first derivative of g. So we can use any x value on that graph if we want to, and then go plug it in over here. So let's go plug in x as 0 as an example. So we can just go plug in x as 0. And what you'll notice is that you're going to end up with 0 minus 5 equals to 0 plus b. And so b is minus 5. Okay, now let's come back up to here. So let's go back up to there. And let's choose another x value. Let's choose this x value over here, which is 5. And so you end up with 15. Oh, and b we know. b is minus 5. And so we can say 15 minus 5 equals to 10a minus 5. And so 10a would be equal to 15 eventually. And so then if you say 15 divided by 10, you would find out that a is going to be, if you simplify, it'll be 3 over 2. Okay, so we now have the a value and we have the b value. I don't know why I went and erased everything over here, but remember we did find b as minus 5. So then we can come back to this original equation as we now have the a value as 3 over 2. We have the b value, and then we just need to find c. But they tell us here that the y-intercept is 25 over 6. So we know that a y-intercept is when x is 0. So when x is 0, y is 25 over 6. That is a point on this graph. And so we can go plug that in now as 25 over 6 equals to 3 over 2. The x's are all going to be 0. And you will end up with c as 25 over 6. So now we have the equation of g. And so the equation of g is now going to be 3 over 2 x squared minus 5x plus 25 over 6. Now, they say determine the minimum value of h. And h is 2 to the power of g of x. So they want to find the minimum value of this. So the minimum value of this will be when this is a minimum. So you want to find the minimum of that. So then we go to this equation and we need to find its minimum, which is, remember, this is a parabola, which is facing in that direction because this number is positive. And so to find the minimum, it's right here at the bottom. It's the turning point. So we know how to find a turning point. We can just say x equals to minus b over 2a. And so if we go do that, we get negative 5 over 2 times 3 over 2, and that'll give us 5 over 3. So that is the x value where the minimum of this graph is taking place, but it doesn't give us the actual minimum. To go find the minimum, you now have to go plug it into here and see what it is. Because what we've just found over here is we've just found the x value of its turning point. That's just the x value. But we don't know what the actual minimum y value is. So we now have to go plug it in. Plus 25 over 6. And we actually just end up with 0. So what that means is that the minimum of g of x is a 0. So then the minimum of this expression is going to be 2 to the 0, and that's actually just going to be 1. So here are all the questions that we're going to do, but I'm going to split them up. They tell us that the graphs of f and g, so the one is a parabola, the one is a hyperbola, are drawn below. The graphs of f and g cut the x-axis at that and that. Okay, do they show us that? Oh no, they actually don't. What? Oh, cut the y-axis. Cut the y-axis. Okay, so then that means that this is at 2.5. So this is 2.5, and then this is minus a half. Okay, one of the points of intersection of the graphs is A, which we can see over there. Point C is the point of intersection of the x-intercept of f and g, and then the vertical asymptote of g is x equals to minus 2. Okay, so we've got this at x equals to minus 2. Okay, first question, and then we have a 6 mark coming up. Jeepers. Write down the coordinates of B. So B is, okay, very easy. We know that it's got an x value of 0 and a y value of 2.5. So I'm just going to say 2.5. 2.5. Okay, this question, calculate the values of A, P, and Q. Right, let's start with P. Because remember, if you have a normal hyperbola, and let's say it's got an asymptote here at x equals to 3, and then it's got another one here at y equals to minus 1, then we know that the normal equation of a hyperbola goes like this. And we know that we can get the P and we can get the Q just from these asymptotes. So remember, because it says x equals to 3 here, we would say y equals to a over x minus 3, because it's a graph that has been shifted 3 units right, and then this would be minus 1. So that's something you need to remember. When you have the asymptotes of a hyperbola, then you can automatically get the P and the Q. So we've got this asymptote. We've got this one. It's at x equals to minus 2. Okay, so we know then that our equation should say y equals to a over x plus 2 plus q. Because when this is negative, then in the equation, it becomes positive. So we can then look at their original expression that they gave us, which was a over x plus p plus q. And if you just make a comparison, we will see that p would be equal to 2. But have you noticed that in some exams, they don't use x plus p over here, they use x minus p? What would you have done then? Well, then all that you would have done is this part still stays the same because it's from the graph. But then if they gave you some equation h and they had it as a over x minus p, they can do that. Different textbooks, different tests, different exams. Then you would just say, okay, so this part must be the same as this part. And then if you had to solve, you would say that p is minus 2. So it doesn't change the equation, it just changes the p-value based on what they decided to use in that exam. Some exams are going to use x plus p, other exams are going to use x minus p. But it doesn't change this part. That part is from the graph itself. Now, if they had given us the horizontal asymptote, if they had told us that that was like y equals to 1, then you could easily get q. But they haven't done that. Okay, so what we have so far is that g of x is equal to a over x plus 2 plus q. So we still need to find two unknowns, and I'm guessing it's going to be two unknowns, we're going to find two equations, and we're going to solve simultaneously. This is why it's worth 6 marks. So all we do is we're literally just going to go find values on this graph. So we've got 1 point over here, and it has to be points on the hyperbola itself. This point is a point on the hyperbola. So we'll plug in the 4 as a y, and we'll plug in the minus 3 as an x, and plus q. Now I'm just going to go simplify a little bit. So a over minus 1. A over minus 1 is just the same as having a negative a. Because a over minus 1, you can think about 1 divided by minus 1. It's just going to be negative 1. So this whole thing just becomes negative 1a or negative a, whatever you're comfortable with. So there we already have a very simple equation. But we still have two unknowns. So now we go find another point on that equation. So we restart, and we can use this point over here. We can't use this point because that is on the parabola. But this point we can use. So remember, it's going to have an x value of 0 and a y value of negative 1/2. So we say negative 1/2 equals to a over the x value of 0 plus q. So we end up with negative 1/2 equals to a over 2 plus q. Now, I think to just make that, oh no, we don't have to do anything, because what we have now is we have two equations and two unknowns. So we can now solve this. You can solve it however you like. What I'm going to do is I'm going to get this q value by itself over here. So I'm going to get 4 plus a, and then I'm going to plug that into here. Okay? If you rather wanted to get the q values equal and then make them equal, you can do that. It's absolutely fine. And so I'm going to plug this q of 4 plus a into here now. So we end up with negative 1/2 equals to a over 2 plus 4 plus a. I should probably make my a little bit, not like a q. Okay, and then we now can, okay, so we can put this a over 2. A over 2 is the same as a 1/2 a. Okay, so we can put a 1/2 a plus another a, so that's going to give us 3 over 2a. And then I'm going to take this 4 to the left. So we end up with minus 1/2 minus 4, which is eventually going to give us minus 9 over 2. I'm then going to get rid of the 2's on both sides, and so we should end up with a equals minus 3. Now that we have a as minus 3, we can then plug it back over here to get q. And as I said, you could have done this in your own simultaneous way. You get q as 1. This one says determine the range of f. So the range is just the y values. So if you have a parabola like this, then to find your range, you need to know what the highest value is at the turning point, and then it goes all the way down to negative infinity. So we need to know what the turning point is. Now, luckily, if you look at the equation, they've given it to us in turning point form. Remember that if I give you an equation, let's make one up. Let's say x minus 3 squared plus 4, then your turning point is 3 and 4. And if I gave you another one like that, then your turning point is negative 5 and negative 3. So when they've given it to you like this, where it's in the general form of ax minus p squared plus q, then you can get the turning point by looking at the p and that q value. And so from this, we can just get it as x as minus 2 and then y as 4.5. So that is the turning point. Okay, so it's actually on that dotted line. Doesn't really look like it. I would say the top is over there, but these drawings aren't according to scale. So we know then that the turning point is going to be at minus 2 and 4.5. Okay, so what we can then see is that the highest value of that parabola is going to be the 4.5, which is this over here. And then the lowest value is going to be negative infinity. So when we give the range answer, it's always the smallest one first. And then the 9/2 is the same as 4.5. And then we include that one because the graph actually does touch that point. If you prefer to use the other format, you could say that y is smaller than or equal to 9/2. Okay, now just remember that there are more questions on the next slide. We've still got 5, 6, and 7. Now, this one, determine an equation for the axis of symmetry of G that has a gradient equal to -1. Okay. When we look at a hyperbola, we know that, I'm just drawing a random little hyperbola. We know that it's got symmetry lines. Symmetry lines are the lines that go through this point here where the asymptotes intersect. So you'll always have one that goes this way, and then you'll always have the other that goes that way. Now, they are straight lines, so it's y equals to mx plus c and y equals to mx plus c. But something we must remember is that the gradient of this one is always 1, and the gradient of this one is always -1. Okay, and they always go through this point. So they said determine the equation of the symmetry line, so it's either going to be this one or this one, which has the gradient of -1. So they want this one. Okay, so they want the line that's going like that. So it always goes through this point. So we know that it's a straight line, so we can say y equals to mx plus c, but we know that the gradient is -1. Now to find c, you need a point. So we use this point over here. So we already know the x value of that point. It's -2. Remember, any point on that line has an x value of -2. And then the y value will be whatever this asymptote is. But we can get that now because we have this equation. We know that the q value is 1. So we know that this y value is 1 anywhere on this line. Okay, so we have that coordinate. It's -2 and 1, and so we can plug that in over here. So we can say 1 equals 2, and then we fill in the x value of -2, and then you get 1 equals to 2 plus c, and then if you solve, you get c equals to -1. So the equation will be that. This question says, determine the average gradient between B and C. So if you look at B and C, if you had to connect them with a straight line, you would see that it's not a perfect straight line, it's more of a curve, right? Because it's a parabola. But what they're asking us to do is just to pretend that it is a straight line, and so we just go use the normal straight line formula, but that is why they're calling it the average gradient. It's not the exact gradient, it's just the average, because, you know, this is a curve, and we're just pretending that it's a straight line. Okay, it's pretty accurate, but it's not the exact way to do it, but that's why they're calling it the average gradient. So we've got the coordinates of B already. We know that the x value is 0 and the y value is 2.5, which is like 2.5. We don't have the c value, Okay, now we also need to find the coordinates of C. There are 3 ways that you can do this. C is the x-intercept of both graphs. So you could use this equation because we do have A, P, and Q. You could also use this equation and go find the x-intercept, or use this one, go find the x-intercept. Or you can understand this property about parabolas. If you have a parabola, and let's say it's like that, and you know the turning point, let's say the turning point is 3 and minus 4, and let's say this x value is 1, then did you know that the turning point is exactly halfway? It's the middle point of a parabola. Okay, if you have a parabola, the turning point is exactly in the middle. It divides it into 2 equal halves. So if you know then that this x value here is also going to be 3, then you can see that this horizontal distance is 2, and so it would be the same on this side, and so you should see that this would have been a 5 in this example. Okay, so your turning point is exactly in between your 2 x-intercepts of a parabola. So if this x-intercept is minus 5, and we know that the turning point has an x value of minus 2, then what is this horizontal distance? Well, to go from minus 5 to minus 2, that's a horizontal distance of 3. So if you then go 3 on this side, if you go from minus 2 and you add 3, that'll get you to an x value of 1. So we can then just say, this is allowed on the memo, you can say that the C coordinate is 1 and 0, and then your reason would be by symmetry. So we used symmetry to help us do that. Your other options, if you feel like more of a longer and a more scenic drive, and you're not in a rush, then you can go find the x-intercept using this equation, or you can go find the x-intercept using this equation. For this one, you're going to get 2 answers. You're going to get minus 5 and 1. So now that we have the coordinates of that, we can now go use our gradient formula, which, as I said, is normally for a straight line, but we're using it on a curve, but that's okay because they said average gradient. And so I'm just going to use this as my point number 2, so that'll be 0, take away 2.5, divide by 1, take away 0, and that should give us negative 2.5 or negative 5 over 2. This question here says, for which values of x is this? Okay, so what this means is, if they say f of x greater than or equal to 0, it means where is the graph of f above the x-axis. So here's the x-axis. So where is the graph of f above that? Well, that would be all of this. Okay? And so that would be from here up to here. So from x is minus 5 all the way up to x is 1. So if you use interval notation, you could say x is an element going from minus 5 up to 1. I'm including because they are including. And then if you instead wanted to use set builder, you could say x is bigger than or equal to minus 5, but smaller than or equal to 1. Okay, so we've done this one and we've done this one. Now this one here says, for which values of x is g of x times by the first derivative greater than 0? So this is one of those scenarios where I would do the that table method that I've showed you guys before. So they want you to multiply this, and they want the answer to be greater than 0. So they want the answer to be a positive. So when you multiply two things together, how do you get a positive? Well, either they both have to be positive, that'll be scenario number 1, or when they are both negative. So then what we do, let's go start off at scenario number 1. And let's specifically go and focus in on this area here. So that means, where is the graph of g positive? What that means is, where is the graph of g above the x-axis? Where are the y values positive? So that would be this little area here, and then all of this. Okay, so that is where that graph is positive. Now, in those areas, are there also places where this will also be true? Now, what is that? Well, remember, this here is your first derivative, which actually just means gradient. So can you see that this hyperbola has a positive gradient everywhere? Can you see that the gradient, it's always going upwards? Even over here, it's still going upwards, okay? So this hyperbola's gradient is positive everywhere. So we know then that where is this part true? Well, we've highlighted it in yellow, and we know that this part is true everywhere on that graph. Obviously not at the asymptote. So where then would both of these be true at the same time? Well, it would be all the areas where the yellow is shown, because this part is positive everywhere, so we don't really need to worry about that one being a problem. So we only really need to look at this one. So now when we give the answer, it's going to be all of this part over here, which is pretty much x can be any number, goes all the way to negative infinity, but then it stops here at the asymptote, which is at -2. Okay, so we'll say that x is smaller than -2. I'll also show you interval notation now. And then this area over here is when x is greater than 1. If you wanted to use interval notation, you could say x is an element from -infinity up to -2, or x is an element from 1 up to infinity. Okay, so that's the answer only for this first scenario. Now we need to go look at the second scenario. So in the second scenario, it's where the graph of g is negative. So it's where the graph of g is below the x-axis. So if this is your x-axis, where is it below? Over here. Okay. And so okay, so we've got that part. But now where is the graph of g? Where does it have a negative gradient? Well, it doesn't, because we said that this hyperbola only has a positive gradient wherever you look. Okay, so this can't exist, and so this part doesn't exist. And so the only answer would be like this if you prefer set builder, or like this if you prefer interval. Now this last one, if h of x is equal to x, okay, determine the values of k for which this expression has two roots that have different signs. Oh, wow. So the first thing I want you to understand is that h of x equals to x. If we just say y equals to x, can you remember what this type of line looks like? That is just a straight line that goes through the origin, and it goes like that and like that. It's like if you're in grade 12, then it's a symmetry line for inverses as well. Okay, so that is what that line looks like. Now, if you were confused about that, I'll show you how easy it is. If, let's say, for example, x is 1, then y would also be 1. So if I had to show you what this looks like, if x is 1, y is 1. So you put a little dot. If x is 2, then y is also 2. So you go to x is 2 and y is 2, and you put a little dot. If x is 0, then y would also be 0, because y is always the same as x. So that would be there. If x is -1, then y is -1. So that would be there. So if you had to connect all of this, that is what that line looks like. Okay. Now, forgetting about k, at the moment, where do these graphs intersect? Well, the one it intersects, f and h intersect there. And then obviously if we had to extend these lines, so if I had to extend this further, then they intersect there. Those are where these graphs are currently intersecting. So those 2 points are called the roots of this equation. The roots are the answers. It's the x values of the answers. So at the moment, we can see that this x value would be a positive number, and this x value would be a negative number. So they said, determine the values of k so that this equation has two roots. So what that means, has two answers that have different signs. So at the moment, this is good. We've got a negative answer here and a positive answer here. Now, if I then say plus k, so if I then have to say like +1, then I'm going to move this straight line up by 1 unit. So then you would get a graph that maybe goes something like this. So it's going to be moved up by 1 unit. So maybe something like that. So now all of a sudden we can see that they are intersecting here and here. And then if I move up by like maybe another 5 units, or maybe if I go here, then we can see that they are intersecting there and there. And then if I keep moving it up, suddenly they're intersecting there and there. And can you now see, if I take all these other ones away, just so we have a bit more space, that we now are intersecting there and there, and those x values are both negative. So now they no longer have different signs. So where did the switch over happen? Because when we were operating down here, everything was good. We had one intersection that was negative and one that was positive, and everything was fine. So if you look carefully, where does that switch happen? Well, you see, if we're there, that's still okay. We've got a positive and then a negative. And then if we go a little bit higher, we still have a positive and a negative. If we go a little bit higher, we still have a positive and a negative. But if we go, you see, look at this y-intercept. If we go above that, then suddenly we've crossed over. Now suddenly we have a negative x value and another negative x value. So it's this part over here that is the critical place where we are switching over. Anything below that point, we have a positive and a negative answer, but anything above that, then we have a negative and a negative. So it's point B that we need to zoom in and look a little closer at. Okay, so this current equation goes through 0. So that's what it currently does. Like I've said, 64 times. Now, if you keep moving it up, and if you get to point B, and if you go beyond that, then you're going to have a bit of a problem. So, and if we keep moving it down, that makes it even better. That's perfectly fine, because now we have a positive, and this is a negative, and that'll never be a problem. That'll just get further and further positive and negative. So we don't need to worry about the going down part. It's the going up part. You can only go up to there, and if you go more than that, then we have a problem. So what do we want the k value to be? Well, can you see that this y value here is 0 and this y value here is 2.5? So then what we can say is that k must be anything smaller than 2.5. So for example, f of x equals to h of x plus 2. So if h of x plus 2, then it means we're moving up by 2 units, and that's still okay. If we then maybe say minus 10, well, then we're moving this line down, and that's perfectly fine. We said that that's okay. If we say plus 3, then we have a problem, because now we are above. So we want to be able to, k can be any number smaller than 2.5. So you don't want to add, you want to be plussing numbers that are smaller than 2.5, like 2.4, or you can even minus whatever, like you can minus 20, that's fine. So we want k to be anything smaller than 2.5. Lester invests 8,000 Rand at 13% per annum compounded quarterly. At the end of the investment, he receives that amount. How long did he invest the money? So this is just a grade 11 kind of question, where we're just going to use the normal A equals P formula. Now, the starting amount is 8,000. The ending amount is 22,350. So we just fill that in for A and P. The interest rate is 13%, so I say 0.13. Quarterly means 4 times per year. Now, for this part over here, you've got two main options. I've seen some learners like to do it one way, some learners like to do it the other way, and then a lot of learners are just very confused about this in general. So I'm going to just put a little star over here. So you've got two options. Option 1 is, let's say for example, this was a 5-year question. Then normally over here you would say 5 times 4, right? So it would be the number of years times 4. So I don't know why I keep drawing the star. So for option 1, you could put 4n over there. In that type of scenario, then n is your number of years. So that would look like this, 4n, okay? So when you eventually calculate your n value, that'll be the number of years. Now, option number 2 is that you don't multiply it with the number of years, you just leave it as n. So you just put an n over there. If you do it that way, then the n is just going to be your number of quarters. Okay, so if I just put n here, then when I solve it at the end, that'll be the number of quarters. Whereas if I say 4n, then this n is the number of years. So I'm going to leave it like that. And now we need to go and solve. So we're definitely going to have to use logs to try get this later on. So what have I always said in financial maths when we need to use logs? Don't round off at all until the very end, because logs are very sensitive if you round off. So what that means is that if you round off, it changes the answer by a huge amount. Okay, and so how would we get this? So whenever I don't want to round off, I don't want to use my calculator until the very end. So what I do first is I divide by 8,000. So I'll have 22350 divide by 8,000. Okay. This I will type on my calculator, just that part there. Well, it's going to give me a fraction. Leave it as a fraction. There we go, 413 over 400, because otherwise you'd have to go write out a whole bunch of decimals. And then 4n. Here's where we're going to have to use logs. Now, what I've been telling learners is that when you go from an exponential to a log, or from a log to an exponential, there's a simple little trick that we can remember. This 413 over 400, we call that the base of this part of here, because it's underneath the exponent. So we call this the base. But now when you write something in log format, then this number down here, we can also call that the base. So when we now switch from log to exponential, or exponential to log, the base stays the base. So this one is going to be the base in the log as well. Okay, so let's write the log. Let's go put the base along. Then all that happens now is, you see how these two are together? When you now switch it to the log, you're now going to have these two together. Okay, and so we're now going to have 22350 over 8,000. That's going to go together now. And then the other part will be on the side, like that. Now you can go type that log in on the calculator, and that'll give you, don't round off, remember? So that's going to give us, or now you can round off because we've used the log. So it's going to give you 32.123 if you keep 3 decimals. Then divide by 4, and so you're going to get 8.03, and that is going to be in years. If you did option 2, you would have gotten this answer here of 32.123, but remember that that would be your number of quarters, and you would then have to divide that answer by 4 to turn it back into years. Brian deposits 700 Rand at the end of each month into a savings account for 15 years. Exactly 5 years after the first payment, 5,200 Rand was paid in the account as an additional payment. The interest rate is 12% compounded monthly. Determine the accumulated amount. Okay, very easy, but can be very confusing if you haven't really done a question like this before, or if you haven't thought about this before. So what you do in a scenario like this, where the person is putting money into an account every month, and then suddenly they decide to just 1 month put 5,200 Rand as a once-off amount. Guys, you're going to do 2 separate calculations. So for now, I want you to completely ignore this one, okay? And just go work out, what is the 700 Rand going to become after 15 years of investing it at 12% compounded monthly. So for that, that will just be the future value formula. Okay, and so the monthly amount is 700. The interest rate is 12%, so I'm going to do that. It's compounded monthly, 15 years, so that'll be 15 times 12, and that'll be there over 12. And let's go work out this so long. Okay, let's not round off right now because this isn't the final answer, but this will be 349,706 Rand, and then let's just go 0.1383. So that is how much the 700s will become. Now, we also just want to check, okay, if this guy went and put 5,200 Rand as a once-off payment, that's not going to go into the future value formula because he only makes that payment once. So we can just go take that payment, and we can just use this grade 11 formula. We take the 5,200 Rand, and we go and compound it for, now just be careful. So remember that on our timeline, we start here right at the beginning and we go all the way to 15 years. It was after 5 years, exactly at the 5-year mark, where Brian deposited the 5,200. So that's going to compound for a total of 10 years. So you're going to say 10 times 12. And if we go work this out, we end up with 17,162 Rand. And then let's just write out all of this for now. Okay, now we are just going to go and add these two numbers together. And so if we then add that together, so we should eventually get our final answer as 366,868.15. Mr. Faku was granted a loan of 900,000 Rand over a period of 20 years. The loan is repaid in equal monthly installments at the end of each month. Everything sounds good up to there. I'm feeling great. The interest rate is 11.5, blah, blah, blah. Everything is fantastic. The first installment is paid 4 months after. Okay, there's where things are starting to get a little bit weird. After the loan was granted. Determine what Mr. Faku's monthly payments will be. Right, guys, so let's quickly go over the basics of the future value and the present value. The basics are the following. Okay, so if we are compounding monthly, then these are the following rules. Your first payment is always done at the 1 month mark, at 1 month, or 1 month after loan was granted. You can think of it like that, 1 month after loan was granted. And then the last payment is on the very last day, on the last day. Okay, so we see here that the first installment is paid 4 months after the loan was granted, but the first payment was supposed to be 1 month after the loan was granted. So how many payments have been missed? Don't say 4, because remember, the first payment was supposed to only happen 1 month after the loan was granted. But now it's happening 4 months after. So 3 payments have been missed. 3 payments have been missed. Okay. So if we now go use the present value formula, because there's another area where a lot of you are going to make a mistake. So let's go write out the formula so long. Okay. A lot of you are going to say, oh, okay, so the loan amount is 900,000, so I'm just going to go put that over there. But that's not correct. What we need to understand about loans is that when you go to the bank and you take out the loan, if you don't start when you are supposed to, which is after the 1 month, if we are compounding monthly, and you rather miss 3 payments, then the loan is going to become larger by the same amount of months that you've missed. So instead of putting 900,000 here, instead you're going to put 900,000 bracket, and then you're going to compound it, which is 11.5% monthly, for 3 months, because 3 payments have been missed, and so you need to compound the loan for 3 months. Then for your monthly payment, that's what we're trying to calculate. Your interest rate is 11.5%, so 0.115 over 12. And now, for your number of payments, if everything was normal, this would have been a 20-year question, so you would have just said 20 multiplied by 12, which would have been 240. But we must remember that 3 payments have been missed. So we will subtract 3, and so we're only going to make 237 payments. So 237 payments. So some of you might be saying, oh, wow. So he would have had to make 240, but now that he missed those payments, he only has to make 237. So is that better for him? Well, no, because the loan, he's missed those 3 payments. Yes, he's only going to pay 237 times, but they're going to cause this X value to become larger now. So he's going to actually pay more every month now. Okay, and then the interest rate is 0.115 over 12. Okay, so we got to get X by itself. So I would try use my calculator as little as possible in this scenario. So I would have the 900,000 1 plus 0.115, whoops, over 12 to the 3. You would then take this over there, so that would become multiply by 0.115 over 12, and then you would divide by all of this. Okay, and so that would be 1 minus 1 plus 0.11, whoa, Kev, slow down, speedster, 115 over 12, 9,908 Rand and 90 cents. Okay, this question over here says, calculate the balance the balance immediately after 16 years is that. So what they're saying there, guys, is remember that Mr. Faku has to pay back this loan over 20 years. And after 16 years, he walks into the bank and he asks the bank, hey, bank, how much do I still owe you? And they say, you still owe us this amount over here. This question, this part says, determine how much interest he paid till the end of those 16 years. Okay, so all that you need to go and do is the following. Because if we look at original loan value, it is 900,000. Then after 16 years, the outstanding, or how much is still left, outstanding, is now going to be 379,811.29. So I now also want to see, or let's first go see, how much has the loan decreased by? So loan decreased. So you can say 900,000 minus 379,811.29, and that'll give us, okay, so it's gone down by 520,188.71. So that is how much the loan has gone down by, but that is not the amount that Mr. Faku has paid because of something called interest. So let's go see how much Mr. Faku has paid. How much has Mr. Faku? Imagine saying that if you are Asian. Hey, Faku! How much has Mr. Faku paid in the 16 years? Well, how many payments has he made up until that point? Well, we know that it's 16 years, so you could say 16 times 12, but then just remember to minus the 3 payments that he missed in the beginning. So that would be 16 times 12, and then minus 3. So he's made 189 payments. So 189 payments, of each one being 9,908 Rand and 90 cents. So how much is that? Well, you could say 189 times 9908.90. Whoa, this bra's been paying me, bro. So this guy's paid 1872782.10. So that means that Mr. Faku has literally made a total of 1.8 million rand in payments over the last 16 years, and the loan has only gone down by 520,000 rand. So he gave the bank just a little bit more than 1.8 million rand, but the loan only went down by 520,000. What happened to the rest of the money? What happened to the other 1.3 million rand? That, my students, is interest. And that is how the banks make their money. So the interest is going to be the 187,278.10 minus the 520,188.71, and that'll give us 1,352,593.39. That is how much interest he has paid. That is almost like that money just disappeared, because it just disappeared. You can't see it. You can't see it in these numbers over here. First principles. So the step one I always tell learners to do is just to go find the first derivative of this using the FOST method. Now, if you had to go find the first derivative of that using the FOST method, you would just multiply this to the front and you would get 2x, and then this part would fall away. So after we've done this long first principles method, we must make sure that that is our answer. All right. So we know that to find the first derivative using first principles, we're going to use this formula, f of x plus h minus f of x all over h. And so, okay. Now, when you see f of x plus h, it means that you will replace all of the x's with x plus h. Okay? And then there's a plus 2. Then we say minus, open up a bracket, and then put f of x. Now, f of x is just that. Okay. And then we just say equals to lim as h goes to 0. And then we're now going to go and expand. So you don't want to put the 2 on the inside and the inside. That's not correct. So you rather make double bracket. And then I'm going to multiply this negative inside. So it's just negative x squared minus 2 over h. And then you'll get x squared plus xh, which is going to be 2xh plus h squared plus 2 minus x squared minus 2 all over h. Hey, we meet again. So here's that part that I always say in every single video. This is the part where everything that doesn't have an h should cancel. So here we can see that this x squared cancels with that. This 2 cancels with that. If that doesn't happen, something has gone wrong, and the thing that's typically gone wrong is you didn't use a bracket over here, and so this is probably a positive and not a negative. And so now we just carry on. Lim h goes to 0, and all we have left now is 2xh plus h squared. Okay, I think I overdid it there. I was a little extra there. Okay, now going into the next step, we can take out a common factor, and that common factor will just be h, and then you'd be left with 2x plus h all over h, and then these would cancel, and so we can say lim as h goes to 0 of 2x plus h. Now we can finally let the h go to 0. The only reason we couldn't let it go to 0 in the earlier stages was because if you make this a 0, then you have a 0 in the denominator, which is not allowed. You don't want your denominator to equal 0. And so it's undefined. And so now we can just go full in the h as 0. So now you don't have to say limit as h goes to 0 anymore. And that's just going to give us 2x. And that's exactly what we said over there. Here we need to find the first derivative. So step 1, we're just going to go and multiply these out. If you're a learner that does AP Maths, or some schools call it further studies or further maths or whatever, so obviously you guys are probably like, yo, bro, you could technically use like the product rule. Guys, don't do that in these normal pure maths exams. Just do the normal basics. So that's going to give us, so we're just going to go multiply this out first. So that's going to be 25x squared plus 35x minus 35x minus 49. Whoops. And that's going to give 25x squared. And then these are going to cancel, so you're just left with that. Now you can go take the first derivative. And so you're going to multiply this to the front. So that'll be 50. And then x. And then this part falls away. So that's the answer. Given that the first derivative of p is equal to 2x3, determine this. Okay. Right. So the first step is to realize that we can go and just simplify this a little bit further. So we can just keep it as p of x. Then when we take derivatives, we want this to be written without the root. So you're going to write it as x, and then you're always going to write it as the inside exponent, which is a 1, divided by the outside, which is 3. Okay, and then this x4, we're going to bring up to the top, like that. Now, there is a rule that says that if you have the derivative of each of these terms, we can just separate it as the derivative of the first one minus the derivative of the second part plus the derivative of this last part, so 5x to the negative 4. And so we know that the derivative of p to the x is 2x cubed. The derivative of this is just going to be a third in the front, and then you're going to subtract 1 from the exponent, so it'll be negative 2 over 3. And then the derivative of this, if you put minus 4 and you multiply it by 5, you get minus 20, and then x, and then you subtract 1. And there's our answer. Given the function f of x equals to that, first question, determine the x and y. So this is going to be pretty straightforward. We're going to find the x-intercepts, we're going to find the turning points, and we're going to sketch the graph. There's no catches involved. So with 8.1.1, determine the x and the y-intercepts. Let's start easy. Y-intercepts, you make x 0. And so if you had to go plug in 0, you just end up with negative 12. So that's your y-intercept at negative 12, and let's just say 0, negative 12. Now to find the x's, we're going to have to go through that whole process of, some learners use block method, synthetic division, it's that process. So to go find the x-intercept now, you need to, so let's just quickly go and say x-intercept. So we know that we make y 0, so you say 0 equals to negative x cubed plus 5x squared plus 8x minus 12. So we have to try factorize this thing, and we need to try break it down into its brackets or its factors, and then we can get the x-intercept. So step 1, when it's a cubic equation like this, is you need to plug in random numbers. So you got to plug in random numbers for x until you get a 0 as your answer, because we're trying to make it equal to 0. Now the numbers that you plug in must always be factors of this number. So the factors of 12 would be the number 1, 2, 3, 4, 6, and 12. We typically won't have to go that high. But then you also want to use the negatives. So negative 1, negative 2, negative 3, negative 4, negative 6, negative 12. We typically won't have to use as many. We should get the answer pretty quickly. So I'm going to start off by plugging in a 1. So I'm going to plug in if x equals to 1. Then what you do is you go plug in 1, but be careful. Some learners, they put this negative x together like that. Rather, you're going to plug it in as minus, then the x is a 1 like that. Okay. and then minus 12. And this will give us, gives us a 0. Fantastic. Now, some of you might use different numbers and you might also get a 0. There is more than one possibility, guys. It's the final answers at the end that will all be the same. So don't worry if you used a different number. We will get the same answers at the very end, okay? So I used x equals to 1. So then we can now know that in bracket form, it'll be x take away 1, okay? It's like having a parabola where your x-intercepts are 3 and minus 1. If you had to put it back into the brackets, it would be x plus 1, x minus 3, right? So your brackets are always opposite to what the value is. Okay, so we have our first bracket, but now we don't know what this part will be. So what we do is we say ax squared plus bx plus c. We don't know what a, b, and c will be. But we know that it needs to eventually look like this. Okay, so what I now tell learners to do is go multiply these two brackets together. If you multiply those two brackets together, it's going to give you ax cubed plus bx squared plus cx minus ax squared minus bx minus c. Then just rearrange everything so that your x cubes are together. Then put your x squares together. And then put your x's together. And then whatever's left at the end. So what we're going to do now is we're just going to go and put ax3 plus bx squared minus ax squared. Oh, I'm never going to have enough space. Okay, there. So I've written them underneath each other now, and I'll check how easy this is. We know that the x3s must be the same, so that will allow us to easily Okay, so what I've done is I've just gone and written the original equation on top of this new expression that we got after we put the x cubes together, the x squares, the x's, and the constants. And then remember what the goal is we're trying to find a, b, and c. So look how easy this is now. Can you see that the x cubes are only those ones over there? So what would a have to be so that it's the same as this? Well, a would have to be a -1. So a must be a -1. So we already have that. So we can fill that in over there. Fantastic. Now, if you look at the end over here, the constants have to add up to -12. So we can say that minus c must be the same as -12. And so if you had to divide by negatives, you should end up with c as 12. So we already have c now. Okay, now it's the b that's a little bit more interesting. So can you see that with the x squares, we could make an equation for those ones over there? So if you use those, you would say 5x squared must be equal to bx squared minus ax squared. You could then ignore the x squares and you'll just be left with 5 equals to b minus a, but we already have a as -1. So 5 would be equal to b plus 1, and so b would be 4. But if you rather wanted to use the x's, you only have to use 1 in an exam, then you would have made an equation with all of the x's. So you would have said 8x equals to cx minus bx, and then you can ignore the x's, so you would just be left with that, and then we already know that c is 12, and then if you had to get b alone, you would eventually get 4. So either way you want to do it. So now we have b. So we now have b as 4. Okay, now you got to try to figure out how to factorize this. Now it is a little bit weird because of the negative. So what you can do, you can take out this negative, or you can take out a negative from here, and you can put it right in the front. Then if you take out a negative from here, it'll be x squared. If you take out the negative from here, it'll be minus 4x. And if you take out the negative here, it'll be minus 12. So if you had to put the negative back inside there, it would be negative, positive 4, which is what we had, and then positive 12, which is what we had. So it's all good. But at least now it's a little bit easier to work with. Okay, there are other ways you could have done that, but now this would factorize into x, and then 6 and 2, and we can put a minus here and a plus here. X squared minus 6, yeah, that works. Okay, and so now we can then, this negative just gets removed by this 0. You can almost imagine if we just said 0 divided by minus 1, that negative is then, you can just ignore it. So all that we say now is that therefore, we can say it here, therefore x minus 1 must be 0, or x plus 2 must be 0, or x minus 6 must be 0. And so the three answers you would get for your x-intercepts would be x equals to 1, which is the first one we found on our calculator, x equals to minus 2, so some of you might have found that one on your calculator, or x equals to 6. Okay, and so we've got the x-intercepts and we've got the y-intercepts. Okay, so just remember that our y-intercept was 0 and minus 12. Technically, these are the coordinates, whereas for the intercept, you could technically just say minus 12, but I just give the coordinates. And then for the x-intercepts, we got 1 and 0, minus 2 and 0, and 6 and 0. Next question, find the coordinates of the turning points. So if you have a graph like that, and you want to find the turning points, can you see that it is the place where the gradient of the graph is 0? See how it flattens out over there? If you had to draw a tangent, it would be completely horizontal. But if you had to draw a tangent anywhere else, it wouldn't be horizontal. So the places where the turning points are is where the gradient equals 0. And we know that gradient is the first derivative. First derivative is your gradient. So we want to find out where is the gradient equal to 0. So we are going to go take the first derivative and we're then going to make it equal to 0. And so if we then go take our first derivative, we end up with minus 3x squared, because I take that 3 and I multiply it to the front, and then I subtract 1 from there, and then plus 10x plus 8. Now we said we want to make that equal to 0. And now you could use the quadratic formula. I think I'm going to do that as well. So in an exam, just write out the formula, show them how you plug in the A, B, and C. But just to save time, because that's pretty straightforward, I'm just going to quickly go do it. So this thing could actually factorize, but you should end up with the x value of negative 2 over 3 or 4. Okay, but now they want the coordinates of the turning point. So what we've just found at the moment is the x values of these points. These are just the x values, but we don't know what the y values are. Okay, and we found the other one as x is 4, but we don't know what its y value is. So to find the y values, you go back to the original equation, because this is y. Some learners, they think that they should go back and plug it in here, but remember that this is the gradient. You're not trying to find the gradient anymore, you're trying to find the y value of the turning point. So you plug it into your original. So if you go plug in minus 2 over 3, some learners here, when they plug, because there's a negative here, some learners do this, they make a mistake. They say, you know, they don't know what to do with that negative. That negative is not with x. There you keep it alone, and then you plug in the x value, which is negative 2 over 3, and then you cube negative 2 over 3 squared. Okay, so I'm going to use, well, I got minus 400 over 27, so I'm just going to leave it like that. And then if you go plug in the other x value of 4, to save time, I'm just going to go get it quickly. You get 36. And so we now have our coordinates of the turning point. So let's just quickly get rid of this, because we'll have to draw it properly just now. So we've now got our x value as negative 2 over 3, and our y value as negative 400 over 27. And then the other x value, or the other turning point, sorry, is 4 and 36. Let's just write that a bit better. There we go. And then lastly, sketch the graph showing the turning points as well as the intercepts. Okay. So these don't have to be drawn according to scale. So the y-intercept is at minus 12. So let's just say, let's put a little point there. Okay, and then the x-intercepts are at 1, minus 2, and 6. So 1, minus 2, and 6. Okay, there we go. Let's just put this a little, I know it's not supposed to be according to scale, but it bothers me a little bit, so let's just put it like there. Okay. Right, I'll put the other coordinates now. I first just want to draw the graph. So this one is at 4 and 36. So 4 and 36 would be like over here. Okay, and then the other turning point is at minus 2 over 3 and minus 400 over 27. So minus 400 over 27 is like minus, it's close to minus 15. Okay, so it's a little bit lower than this point because this is minus 12. So it's going to be like there. Okay, now we have to try draw a nice graph that goes through there. Oh, he misses it. And there, and then there, something like that. Okay, and then let's pretend that I nailed that one over there. Nailed it, nailed it, nailed it. Now you want to go give all the coordinates. So this is going to be 4 and 36. 6 and 0. What was this one? 1, minus 2. And then this weird one, which was minus 2 over 3 and minus 400 over 27. Given that f of x is equal to that expression and g of x is equal to that, g of x is the second derivative of x. Below is the sketch of g. Okay. Calculate the values of k and p. Interesting. So I don't know how this question is going to go. I don't know what it's about, but all I know is the following. They tell me that g of x is the second derivative of f. So let's go find the second derivative of this. So I know that its original equation is kx cubed plus px squared plus 4x minus 3. So if I take the first derivative, it'll be 3kx squared. So I just multiplied that 3 to the front. So 3kx squared plus 2px plus 4. Then I take the second derivative and I multiply the 2 to the front. That'll be 6kx plus 2p, and then the 4 would cancel out. Okay, so I know now that that is my second derivative, and I've been told that that is the same as g of x, which is that. So I'm going to make them equal, so minus 6x plus 10. Now, what you need to do within this scenario is the following. There's a little trick we can do here. So remember that this part here is the graph of the second derivative, and this part here is the graph of g. Now, if you look on the graph of g, which is over here, can you see that it can have any x value? If you just keep going, this graph would keep going to the left, and this would keep going to the right. So any x value on that graph, you know, that graph has any x value. And so you can plug any x into this thing's equation. But we already know that the g graph and the first and the second derivative graph, they are the same thing. So they'll have the same x values. They are the same graph. So you can go plug any x value that you can see over here, which is any x value, because this graph would just keep going to the left and it'll keep going to the right, like I said. So what we can do now is we can just go plug in any x value. We're not plugging in a point. We don't know any coordinates. It's not like I'm not telling you to plug in a specific point. You don't have to plug in an x and a y. I'm just saying, because look here, this equation doesn't even have a y. It just has x's. So you can then take any x on here. So I'm just going to take x as 0, which is that point over there, and I'm going to go plug it into this equation. And so you're just going to end up with 2p equals to 10 eventually, because this cancels out and this cancels out. And so you end up just getting p equals to 5. How cool was that? Now, just go do that whole process again, but just choose another x value. You can choose 100, you can choose 1,000. I'm going to just choose 1. And so if I take 6kx plus 2p equals to minus 6x plus 10, and I go plug in 1, then I end up with 6k plus 2p equals to minus 6 plus 10. And so we now know that P is 5. And so if you eventually had to go and solve this, you would realize that the 10s are going to cancel, and so K is minus 1. And so there we go. How easy was that? So we have K as minus 1. I've seen this type of thing happening in 3 exam papers now that I've recorded over the last week. So it's quite interesting. They seem to be throwing this in quite a bit. And then P is 5. Okay, this one for 2 marks. For which values of x is f of x concave up? So we know that concave, okay, so when we talk about concavity, it tells us about, well, I'm not going to go into the absolute details. I'm just going to tell us what we need to know for this question. We know that if your second derivative is positive, then we call this concave up. And if your second derivative is negative, we call this concave down. Now they've given us the graph of g, but g is the second derivative. So you can make them, they are the same thing. So literally you can take this away and you can just make this that. Now we want to know for concave up, it's where this is positive. So where is this graph positive? Positive just means above the x-axis. So if this is your x-axis, then where is the graph above that? Well, it's from this point onwards, and we don't have that point. Oh, of course, but we have the equation of the original graph g, and so we can go get that point because that is the x-intercept. So we make y 0, and so you would end up with 0 equals to minus 6x plus 10. If you take the 6x to the left, you divide both sides by 6, it should simplify to 5 over 3. So we now know the x value here is 5 over 3, and we said that the graph is going to be concave up when it's above the x-axis, and so it's above the x-axis, all of this, and so it's for all the places where x is smaller than 5 over 3. If you prefer interval notation, you could say x is an element going from negative infinity up to 5 over 3. We're saying that it's all of this area, okay? That is where it's above the x-axis. The sum of two numbers is 25. Determine the two numbers such that the square of the one number plus 3 times the square of the other number is a minimum. Okay, so it sounds crazy, right? But let's just start at the very beginning here. So we've got two numbers, so let's call them x and y. The sum, so when you add them together, should give you 25. Whoa. Okay. Now, determine what the two numbers are such that the square of the one number, so square of the one number, plus 3 times the square of the other is a minimum. So we want this thing to be a minimum. Now, how do we normally find the minimum of something? We take the first derivative and we make it equal to 0. The problem is we can't take the first derivative of this just yet because there's more than one variable. We've got x and y. But they've given us this information over here. So all we do is you just go get one of these by themselves. I'm just going to get the x by itself. So 25 minus y. But if you got the y by itself, it doesn't matter. So I just got the x by itself. And I'm then going to go plug that into this expression. So 25 minus y squared. See, I just replaced it over there. Plus 3y squared. And I want this thing to be a minimum. So let's just call this expression t as an example. They haven't really told us what we can call it. I'm then just going to write it the other way around because I'm feeling a bit dizzy with everything on that side like that. Okay. And now we're just going to go multiply out these brackets. So we'll put 2 brackets and then plus 3y squared. Let's go simplify. So 25 times 25 is 625. Then minus 25 minus another 25y plus y squared plus 3y squared. And we're just going to go simplify now. So that's going to give us 4y squared minus 50y plus 625. Now you want to find the minimum of this expression. So to find minimums, we take the first derivative. So that'll be 8y minus 50, and then this part falls away. And then to find minimums, you take the first derivative and you make that equal to 0. So we're going to say 0 now is equal to 8y minus 50. Solve for y, and you should end up with 50 divided by 8, which is 6.25. Okay, and then to find the other number now, we can just come back to this expression, and so we can just say that x will be 25 minus 6.25, and that's going to be 18.75. Two mutually exclusive events A and B are such that the following and the following. Okay, so when two events are mutually exclusive, it means that they cannot happen at the same time. For example, someone doing maths literacy and doing physics at the same time. So the circles would not overlap, they would be separate. So when two events are mutually exclusive, they cannot occur at the same time. So we say that the probability of A and B is 0. And graphically, this is what it looks like. The circles don't intersect, because this part over here, that is your A and B. But when two events are mutually exclusive, that part doesn't exist, because you cannot have both of them happening at the same time. You cannot have someone doing physics and maths literacy at the same time. Okay, so that's what it's going to look like graphically. So A and B. Now it says that the probability of A is 0.5, and then it says not B is 0.7. So not B, so ignore B, and everything outside of B must add up to 0.7. Now we know that this already adds up to 0.5, so then that means the outside must be 0.2. And now we can easily work out what the probability of B must be for this first question, because we know that everything should add up to 1. That is how probability works. And so let's just put this A nicely over there and B nicely over there. So if we say 1 minus 0.5 minus 0.2, that'll be 0.3. So this is 0.3. This question says, determine the probability that it is not A or B. Okay, let's first just go work out what is the probability of A or B. Now we know that there's this formula in our formula sheet that goes P of A plus P of B minus the P of A and B. Now first of all, if we just had to go work this out, probability of A is 0.5, probability of B is 0. We got that, sorry, I don't know why I erased the Venn diagrams. We had A as 0.5, we had this as 0.2, and we had this as 0.3. So just want to make sure those were the numbers that we said. Yeah, I'd have the 0.3 over there. Okay, so just make this a little bit bigger. Now, probability of B then was 0.3. And we said that because they are mutually exclusive, we said that that part is 0. So then the probability of A or B is 0.8. Okay, now it says, what is the determine the probability that it's not A or B? Well, we know that all of this must add up to 1. All probability must add up to 1. So if it's not A, so if A or B is 0.8, then not A or B would be 1 minus that. And so it's the 0.2. So it's actually just that over there, but for 3 marks, we kind of had to show some calculations. A survey was conducted on the digital devices that learners own. A certain number of learners were surveyed, and the results are recorded. The survey revealed that there were learners owning cell phones, tablets, laptops. Below are the results on the Venn diagram. Okay, so cell phones, tablets, and laptops. First question for 3 marks says, determine the value of x and y if the probability of owning at least one of the devices is 9/10. So the probability of owning at least one of the devices. So that would be all of this. That would be all of this. Because people who own one device only would be these people over here. So these people here only own a cell phone. These people only own a tablet, and these people only own a laptop. But they said at least. So you can have more than one device. So now these people here, they own a cell phone and a tablet. Okay? These people here own a cell phone and a laptop. These people here own a tablet and a laptop. And then these people here, they own a cell phone, a tablet, and a laptop. So all of those fit into this thing over here because it says of the probability of owning at least one of the devices. So that's all of these people. They all own at least one of the devices. Some of them own one, some of them own two, some of them own three, but we can say that they all own at least one of the devices. So all of that must equal 9/10. And so we literally can go say then that 13/30 plus 1/15 plus 2/15 plus x plus 1/50, your fraction for days, plus 1/75. All of that must add up to 9/10. And so here's x. So if you wanted to get x, you would take everything to the right-hand side, and you should eventually get 1/5. Okay, so x is going to be 1/5. So we've got that. And then to find y, because we need to get y as well, remember they've told us that all of these things in the circle adds up to 9/10. So we know that all probability, so everything inside this square, should add up to 1. So we can then just say that we found x as 1/5, and then y is going to be 1 minus all of this, which we already know is 9/10. And that's going to mean that y is equal to 1/10. So y we said was 1/10. Now this question for 1 mark, thank goodness. Calculate the probability that a learner owns a cell phone and a tablet. Now they need to be a little bit more clear there. Can the learner also own a laptop? For example, principal walks into the school and says, can everyone that owns a cell phone and a tablet please stand up? The people who have laptops as well, they would also stand up, right? So you see how the question's not extremely clear about what they want. Do they mean cell phone and tablet only, or do they mean a cell phone and a tablet? Because then you can also own a laptop. It didn't say and not a laptop. So let's have a look. I will obviously look on the memo, but I think what they mean is just cell phone and tablet, but it doesn't matter if they also own a laptop. So where are the people that own a cell phone and tablet? So cell phone and tablet is where the cell phone and tablet circle intersects. So here's the cell phone circle, and here is the tablet circle. So the answer is either this one, because then it's cell phone and tablet only and not a laptop, or it's the intersection over here where we're allowed to also have a laptop. So I think it's that one, but I will go look on the memo. So if you add those together, you get 4/15. So I went and looked on the memo, and this is correct. So they said, yeah, calculate the probability that a learner owns a cell phone and a tablet. They didn't say, and not a laptop. They imagine your teacher walks into your classroom and says, can everyone who owns a cell phone and a tablet please stand up? If you have a laptop, you're not going to stand up. You're not going to be like, ma'am, I have a laptop as well. She didn't say, and not a laptop. She just said, if you own a cell phone and a tablet, stand up. So even if you have a laptop, you're still going to stand up, right? And so, but they could have made this a little bit more clear. Lastly, this one says, if the total number of participants is 150, okay, calculate the number of learners who own laptops only. So laptops only are these people over here. So you can just say 1 out of 50 multiplied by 150, and that's going to be 3. Codes of 3 symbols are formed using the 26 letters of the alphabet and the 10 digits. Repetition is allowed. Okay, so we're making codes, guys, and the codes have 3 spaces. That's what they mean when they say 3 symbols. And we can make these codes using any of the 26 letters of the alphabet and any of the digits, and repetition is allowed. So we can make codes like A5 or 631. It doesn't have to have letters at all. Or it could maybe only be letters like F, G, W, or you could make any kind of combination. You could repeat letters like A, because repetition is allowed. You could literally just have 3 digits. It doesn't matter. Repetition is allowed, and it must just consist of any letters or any of the 26 letters and any digit. But it can have only letters or only digits. So there's quite a lot of options that you have on the types of passwords we can make. So this first question says, how many codes can be formed using at least 1 letter? Okay, now that's a bit of a, it's going to take a long time to go solve that because they said at least 1 letter. So, you could make, I'm going to show you a faster way. So if you had to go at least 1 letter, that could be all the passwords that have 1 letter. It could be all the passwords that have 2 letters, and it would be all the passwords that have 3 letters. So you would have to go calculate each of those scenarios. What if we rather just do the following? What if we rather go see how many passwords can we make that have no letters? Okay, so no letters. Well, then you only have the digits available. So for the first position, you have 10 digits available, 0 to 9, that's 10 digits. 1 to 9 would be 9, but then we also have the 0. For the next position, we still have 10 digits because repetition is allowed. And so that would be 1,000. So that means there are 1,000 passwords that we can make that don't have any letters. The next thing I would ask you to calculate is, what is the total number of passwords that we can make for this entire system over here? Like in total, how many passwords can we actually make? Well, when you look at your first position, you have 26 letters available, or you have 10 digits available. So you've got 36 different things that you can choose, right? For the next position, you also have 36 different things you can choose. And for the next position, you also have 36, because you can choose any one of the 26 letters or any one of the 10 digits. So that would be 46,656. So guys, what this means is that if we had to look at it like this, there is a total of 46,656 passwords that we can make. Now, 1,000 of those don't have any letters. So then what would you say about all of these other ones? They have letters. Some of them have 1 letter, some of them have 2 letters, some of them have 3 letters. So if we simply now take this number minus this number, then you get 45656. And then you've solved this question, because it said, how many codes can be formed using at least 1 letter? So what I went and did is I went and calculated the total number of passwords we can make, which is 46,656. I then went and calculated how many passwords have no letters, and that was 1,000. So then all of the remaining ones must have letters. Some of them have 1 letter, some of them have 2, some have 3. It doesn't matter, as long as they have at least 1 letter. And so the answer is going to be the 45,656. This last one says, what is the probability that a code from question 11.1 will start with a vowel and the second and the third symbols form an even number? Okay, when I read that the first time and I actually went and did the question, I realized from the memo that they didn't explain the question very nicely. I thought that they meant the following. So the first one must be a letter, so like A, and then the second and the third space must be an even number, so like a 4 and an 8. But what they meant was that this number together must be an even number. So it could even be like 36. So even though that part there is not an even number, the number 36 is an even number. That's what they meant. Okay, so they didn't mean that this one must be even and this one must be even. They just want this number to be even. So that means that this one doesn't have to be it doesn't have to be an even number, but they want this whole thing to be even. So what this then means is that for the first position, it has to be a vowel. So out of the 26 letters of the alphabet, there are 5 vowels: A, E, I, O, U. I should be an English teacher. And then for the next position, or let's rather look at the very end, for this number to be an even number, it's only the last digit that has to be the even number. So you could have 0, 2, 4, 6, and 8. So that's 5 different options there. And then for this one here, it could be any of the digits. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that would be 10 different options over there. And so if we had to work that out, that's going to be 250. And so now we're going to say probability is going to be 250. But now they said that it must only be out of the codes that we formed in 11.1. So there were only 45,656 of those. And then if we had to go simplify this, it'll be 125 over 22828, 22828.